The AP test is tomorrow. So just
Oh,
wanted
the
to
AP
get some.
test is tomorrow. Okay.
It is.
How
Just wanted to
long?
get some last minute review.
Yeah, how long is that, an hour test, or is this an example of it?
Um. Oh yeah, it is. It's a 3 hour test
Wow.
ish.
Okay. Let's look at this first one.
Okay.
What rule are we going to use to find this derivative?
We have to use the product rule.
Okay, the product rule says that one thing times the derivative of the other plus the derivative of the first times the second. So it doesn't matter which one you do first. So if we take the derivative of x, we get 1 sine x plus x times the derivative of sine x, which is cosine x. So it's plus, not minus.
I think I got mixed up with the integral there, the antiderivative.
Right. That's what I thought you did when I saw this, is that when you take the integral of sine, it's negative cosine. Okay. Which of the following intervals is the function increasing? So we're going to take the derivative, which you did, and do what with it?
So we have to see where it's positive for the first derivative.
Exactly. In other words, the function is increasing whenever the first derivative is positive, so I set that greater than 0. Okay? And now solving that, I get 300 is greater than 3x squared, or 100 is greater than x squared, which means what?
So that has to be greater than 0.
Well, if 100 is greater than x squared,
Oh, then you can square root it. And then,
I can square root it and say 10 is greater than x, but whenever you square root an inequality, you have to take the other end of it also. In other words, this is plus or minus 10, so minus 10 would be less than x. So x has to be greater than minus 10 and less than 10, which is b.
right.
And notice, if 100 is greater than x squared, x can certainly be minus 5 or minus 6 or anything from 0 to minus 10.
Mhm.
Now, the only thing that's a little puzzling here is that they have brackets around answer B, which I'm a little puzzled by, because if x is actually equal to 10, then f of x is not positive, it's equal to 0. So I don't know that the function could be said to be increasing when f prime of x is equal to 0, but I won't quibble. Since they all have brackets instead of parentheses, obviously the brackets have to be the answer. All right, let me go down to the next one. Integral of secant tangent. What's the derivative of secant?
Isn't that secant tangent?
Yes.
So that, yeah.
If secant tangent is the derivative of secant, then the integral of secant tangent has to be secant. So it would be A, secant x plus c. Notice that you have to be able to take the derivative of your answer and get this. Well, if we took the derivative of tangent, that's secant squared. But if we take the derivative of secant, we get secant tangent. Okay. Before we can evaluate f prime of 1, we need to solve for f prime. So f prime of x is equal to what?
It'd be 7 plus 1 over x.
Now what's f prime of 1?
So that'd be 7 plus 1 over 1, so 8.
Yeah. Okay, I didn't stop and check to see whether you had the right answer there. You did. So I don't know if that means we don't need to cover it, or I know that we're probably looking at 55 questions. I doubt that we're going to have time to cover all of them. So
Yeah.
I don't know. Let's have a look at. In fact, if there are some on here that you want to make sure you cover tonight, you tell me that. Otherwise, I'll just keep going, and we'll go until 9 o'clock.
Okay. I can look through and see.
Okay. So if that's the graph of f, which of the following statements is false? The limit of f of x as exists as x approaches 2. Is that true or false?
Isn't it true because both the left-hand limit and the right-hand limit are the same?
Yeah, what is that limit?
That'd be 2.
Okay. The limit of f of x as x approaches 3 exists. Same thing.
Mm-hmm.
The limit of f of x as x approaches, is that 4 from the negative?
It is.
Okay. That actually does exist if it's 4 from the negative.
So it is just a regular 4, not a from the negative.
Ah, okay. In which case it doesn't exist because it's different from the right than it is from the left. But it would exist if that was approaching 4 from the left side.
Right.
Now let's just have a quick look at the others. As x approaches 5, that limit clearly exists. And the function is continuous at x equals 3. And that's true also. Is it differentiable there?
No.
Okay. If I start to go over one that you don't need to go over, stop me and we'll go on.
All right.
Okay. So this is an integral as net change problem. And we know that because velocity is a derivative. So to get the total distance traveled, we clearly are going to integrate the velocity function from 0 to 3, looks like you do that just fine. 3t squared minus t cubed over 3. And that is 18 minus 0, so that looks correct. Do you know the answer key on these?
I do not.
Okay. If y equals that, then y prime is, so it would be 3, let's write this out again. So here we're going to use the chain rule. So what's the derivative of the outside?
That'd be 5u to the 4th.
So u is that. And then what's the derivative of the inside?
That would be 3x minus
3x squared.
Yeah, 3x squared. And that'd be plus sine, or yeah.
Yes, the derivative of cosine is minus sine. The derivative of sine is plus cosine. So before we do anything further, like distribute that all out, let's check and see if that's an answer, and it is. E. In other words, you don't really have to use U substitution for these. And had you not used U substitution, you probably would have gotten it right, because that's U, but what it really means is the derivative of the outside times the derivative of the inside. So I don't really need to use U, just use whatever's in the parentheses.
Okay.
Okay? Because somewhere in the translation it looks like you got the wrong thing there. Okay, let's see. Okay, this is again integration as net change. We have a rate that it's being pumped in, and we have an initial starting amount. So we're going to find the area under the curve. We don't have a function, but they give us the next best thing, which is a table of values. So I have a bunch of points, and you've plotted those points. You've used the right Riemann rectangles to figure this out, and we want the area from 4 to 15, so we only want these 3 rectangles. And it looks like you've done this correctly. 3 times that amount, which is 18.6, plus 5 times that amount, plus that. Does that give you 114? It doesn't look like it does.
It gives me 64.9, and it has the initial value of 50.
Ah, thank you. So you got that one right. You don't have any questions on that?
No, I think I got those sorts of problems pretty well down.
Okay. For what value of k is f continuous at x equal 2? First of all, what does this say? It's equal to that for x equal to 2?
X does not equal 2 when x does not equal 2 for the first one, and then for x does
equals 2 for the second one. Okay.
Right.
So let's see. So you graph this first curve with the hole at x equal 2. That graph is 2x plus 1, has a y-intercept of 1, a slope of 2. That looks correct. And at 2, k would have to be 5. I presume 5 is on that line there?
Yeah, I think so.
Okay. So that fills in the hole and gives us a continuous linear straight line. Let's see, if we substitute 5, what do we get? We get 11 times 3. 33 divided by 3 is 11. Oh, when x equals 2, I want k to equal whatever k is equal to when x equals 2. And you solve it using just this part. All right. Looks like you understand that pretty good too. So y equal e to the x over 2 must look something like that. And x equal 2. So what is the area in the first quadrant? Notice that we don't need to subtract the 2 here. In other words, we're looking for this area right here, which is merely that function evaluated from 0 to 2.
Right.
So it's the integral of e to the x over 2 evaluated from 0 to 2. What's the antiderivative of e to the x over 2?
Is that e to the x, or?
It's the same thing, only then you have to divide by that coefficient, or in this case, multiply by that.
Oh, okay.
In other words, I'm going to divide this by 1/2. So take the derivative of this. That would be e to the x over 2 times the derivative of the inside, which is 1/2, gives you back e to the x over 2. So this is the antiderivative of that. And we want to evaluate it from 0 to 2. Well, evaluated at 2, it just becomes 2e. And evaluated at 0, any number to the 0th power is 1. So there's my answer. That's not on there, but that's because they factor out a 2 and leave e minus 1, which is, oh, it is on there, a. Yeah. Well, once again, if you understand the problem, stop me in mid-sentence if you like, and we'll go on, because I'm sure you'd read it.
That was a good one to go over
Okay.
again.
Okay, good. Because I'm not really checking your answers to see if they're right here. So f is defined as square root of the absolute value of x minus 2 for all x. Which of the following statements is true? Well, let's graph this. Square root of x, and this is the square root of x minus 2. So it would look something like that, and its other half must look like this. So f is continuous but not differentiable at x equal 2. Well, that's exactly what that curve looks like. Looks continuous but not differentiable there because it's a cusp.
Right.
F is not differentiable there. F is not continuous there. Well, that's false. That's false. The limit of f of x is not equal to 0 as x approaches 2. That's false. X equals 2 is a vertical asymptote of the graph. That's false also. Vertical asymptotes don't come to cusps. They come with graphs approaching infinity as they approach the vertical asymptote.
Okay.
Okay. The only thing difficult about that was probably coming up with this curve.
Yeah.
Because if you take away the absolute value, the curve is just that. And now, is that differentiable at x equal 2? No.
Without that, yeah.
Well, no, I was kind of muttering to myself. All right, you got this right. Let's go on rather than ponder that point. All right, using substitution. Since we're going to let u equal square root of x, this is e to the u over u. And what's the dx become?
du.
No, let's solve for du dx. In other words, if u is going to equal square root of x, then what's du dx equal? Square root of x can be written x to the 1/2. So du is what?
It'd be dx to the 1/2 or 1.
That'll be 1/2 x to the minus 1/2.
Oh, okay.
Okay. And now we got to solve for dx, so we multiply both sides by dx. So now du is equal to 1 over 2x to the 1/2 dx, which makes dx equal to 2x to the 1/2 du. Do you see every step that I went through there?
Yeah, I think so.
Because we need to substitute for dx. We can't take this integral if I put a dx there. You can't integrate a function of u with a dx. So I got to substitute for dx also, and it turns out that dx is equal to that. So I can write 2x to the 1/2 du. Well, right offhand that doesn't look very good, but we know that x to the 1/2 is u. So we'll put that in there like that. Now the u's cancel, and we have an integral that's fairly easy to integrate. Let's take the 2 outside. So the whole thing becomes this. What's the antiderivative of e to the u? Or what's the integral of e to the u du?
So that'd be u e to the u minus 1.
No.
Or
The
no,
antiderivative of e to some power is that. In other
right.
words, the antiderivative is e to the u. So this is going to be 2e to the u evaluated, but I really can't evaluate that from 1 to 4 because the limits of integration change as soon as I use u. So either I have to resubstitute for u and evaluate it from 1 to 4, or I have to figure out what those limits do when u is equal to the square root of x. Notice that when I go from 1 to 4 with x, I'm really going from 1 to 2 with u. So if I want to evaluate this with u, I've got to change my limits of integration like that. Or if I want to evaluate it at the original limits of integration, I have to resubstitute for u again. Now I can evaluate it. It's probably easier to substitute back in and evaluate it at the original limits of integration than it is to find the new limits of integration. So what is this? And it just occurred to me that I looked at the answer and they don't have an answer. All of their answers are in integral form. This is a classic lesson as to look at the answers before you attempt to solve it. So let's go back one step. Since all of my answers are the integral of e to the u, I can't resubstitute. I've got to change my limits of integration. And they have to go from 1 to 2. You see how they go from 1 to 2?
Yeah.
In other words, if x goes from 1 to 4, then what does u do? Since u is equal to the square root of x, u goes from 1 to 2. So C is the correct answer here. Okay. And you solve that by just solving the two triangles? Or
Yeah.
this rectangle here is 5 times, what's this 6?
Well, that was the area of that rectangle that I got.
Okay, now we need to go from 1 to 5. So when we go from 1 to 3, that little, in other words, it looks to me like you maybe counted a section twice. But 1 is here. 5 is over there somewhere. And 3 is the delineation. So we want the area of that rectangle, which is 4 times 2. So that's 8. And we're going to add the triangle to that. And the triangle has a base of 2 and a height of what? Let's see, when x is 5, this is 4. So that is 2 times 2, which is 4, plus half of that. So the area of this little triangle is 2. So the total area is 8 plus 2. When you did
Right.
6
I went
plus
from
2,
0 to...
you went from 0 to 5 instead of 1 to 5.
Yeah.
Okay.
Must not have read it carefully enough.
Well, that's okay. So the derivative of the composite function. Well, how do we take derivatives of this? We do it using the chain rule.
Right.
In other words, we're going to take the derivative of the outside, which is f prime of g of x, times the derivative of the inside, which is g prime of x. Let's see, what exactly did you do? It looks like you did this correctly. Then you take the derivative of that. Let me think about this for a second. If I take the derivative of the outside of this composite function, I get 1/2 x squared minus 4 to the minus 1/2 times the derivative of the inside, which is 2x. So that's the derivative of the outside of the function. Then I have to multiply it by the derivative of g of x, which is 3. And then I want to evaluate that whole thing at x equals 3. So what is that? Let's see, that's 1/2. Let's see if I'm doing this right. Times 9 minus 4, 5 to the negative 1/2, times 6 times 3, so times 18. So this would be a 9. So my answer should be, if I've done this correct, 9 times 9 divided by the square root of 5. It's not on there. I must have made a mistake somewhere. Okay, let me do it the way you did it. By figuring out what that composite function is and then taking the derivative of it. So we end up with 3x minus 2 squared minus 4 all to the 1/2. And then we need to take the derivative of this and evaluate it at 3. Probably the easiest thing to do here, because we could apply the chain rule twice, but I'm going to expand this inside, making it a little easier. I'm going to go ahead and square that, making it 9x squared minus 12x plus 4 minus 4. So the 4's cancel, and now we have to take the derivative of that. Taking the derivative of the outside, times the derivative of the inside there's our derivative of that composite, evaluating it at 3. 1/2 81 minus 36 to the negative 1/2 times 54 minus 12, which is 42. 42 cancels with this 2 to make 21. We have 21 over 45 to the 1/2. 45 is 9 times 5, so that's 3 root 5. And that answer is on there. 7 over root 5. Everything I've been telling people for the last 3 years was just proved false. I told them you would never find an answer on a multiple choice test that has an irrational number in the denominator. Yet this does. I'm not quite sure why my first answer didn't give the right answer. I might have made an arithmetic mistake the first time through, but this clearly has to work this way. I was kind of trying to take a shortcut when I did it the first time. Whereas figuring out what the composite function is exactly, which is what you did here, and then taking the derivative of that is the better way to do it. That has to be right, whereas my shortcut technique probably was wrong. Must have done something wrong in my math. Okay, I assume that there's only one graph here that was originally on this?
Yeah.
Okay, if h of x minus the integral from 0 to x of that function, which of the following is true? That says if h of x equals the integral of that. Right?
Yeah.
That's an equal sign?
Yeah.
So if some function h of x equals the integral of this function from 0 to x, which of the following is true? What'd you do here? How'd you do this?
I'm not too sure. I think I was trying to figure out the derivative, the value of the derivative,
Well,
or something.
if h of x is equal to that, then we can figure out what h prime of x is equal to. We have h of x equals an integral. Well, this looks a lot like the fundamental theorem of calculus. If I take the derivative of both sides with respect to x, what's the right side become? Left side becomes h prime of x. What's the derivative of the integral of f of t going from 0 to x? It's that.
Just f of x? Okay.
Just f of x. And that's true whether this goes from 0 or any number. If I was going from 4 to x, it would be f of x. So I can make this statement based on this part of the thing. So now, which of the following is true? Well, what's h prime? So we've got h of x, and we've got two different derivatives. So which is greater, which is less? I'm going to think about this for a second. So the first derivative is equal to f of x. So this is our first derivative chart. This is h of x that we're looking at. Excuse me. This chart that we're looking at here is h prime of x.
Right.
So h prime of 6 would be what?
0.
Okay. Let's write these out. So h prime of 6 is equal to 0. What's h double prime of 6? Approximately equal to. What's the slope right there? In other words, if this curve represents h of 6, then h prime of 6 is the curve of these slopes. Well, the slope right there is about 1. So I can approximate it for the time being. So I know h double prime of 6 is greater than h prime of 6. Question is, what is h of 6? Well, h of 6 has to equal the integral from 0 to 6 instead of x of f of t, which is this function that we're seeing here. If I integrate that function from 0 to 6, I get what? Negative area, right?
Yeah.
So h of 6 has to be a negative number, less than 0. Since h of 6 was equal to, in other words, if I go right here and I substitute 6 for x, I got h of 6 is equal to the integral from 0 to 6 of this function. Well, I can look at this function and see that the integral from 0 to 6 is all below the x-axis, so it has to be a negative area. So I know it's negative. So the right order is h of 6 is the smallest, h prime of 6 is next, h double prime of 6 is last. So A, you got it right. That was a toughie, actually.
Yeah.
For me, it was a toughie for sure. Where A and B are constants and A is not equal to B. For which of the following values of t is the particle at rest? This is the position function that they're giving us. So when is the particle going to be at rest?
Is it when the velocity is 0?
Yes. So to get the velocity function, what do I have to do?
I have to take the derivative of the position function.
Right. Okay, so let's figure out what the position function is again. It's t squared minus at minus bt plus ab, where a and b are numbers. So the velocity function is the first derivative of this. So that's 2t minus a minus b. There's your velocity function. We're going to set that equal to 0. So 2t minus a minus b is equal to 0, which means 2t is equal to a plus b, which means t is equal to a plus b divided by 2.
Right.
That's the first one you've missed in a while. All right, let's see here. My head's starting to hurt. Okay, let's see. If f of x is equal to that, which of the following could be the graph of g of x? Well, again, based on the fundamental theorem of calculus, if f of x is equal, now remember, it doesn't matter what number it goes from. If it goes from some number to x of g of some dummy variable, and this doesn't matter either, if I take the derivative of an integral, I'm going to get g of x. So if I take the derivative of both sides here, I get f prime of x on the left, and I get g of x on the right. In other words, when you take the derivative of an integral, it basically equals that function, as long as the upper limit is x. If the upper limit is x squared, then you have to apply the chain rule, and you have to multiply this by 2x. But as long as that upper limit is x, then this is true. So we want the graph of g of x, right?
Yeah.
And we know that g of x is the first derivative of f of x, and this is f of x. So what's the derivative of this function right here? Remember, derivative is slope.
Oh, right. So it'd be 1?
It's a constant.
Yeah.
So the derivative, whatever this slope is, I don't know if that slope is 1 or 1/2, but if I take the derivative of this function, I get a constant. And a constant is going to show up as y equals a straight line. Notice they don't even label the y-axis because they didn't label this y-axis, so we don't really know what that slope is. We just know that it's positive. And if I took the derivative of this function, I would get something like a. And it's a positive slope, as opposed to b, which is a negative. b is y equals a negative number. A is y equals a positive number. Certainly
Right.
isn't C, it isn't D, and it isn't E. The key is knowing that if this is our original function, the derivative of that is a horizontal line, positive horizontal line. All right, that wasn't so bad. Boy, a couple questions there that you need this principle here. Let's just
Yeah.
review that principle. If you have an integral from any number, I'll call it A, to x of f of any variable, I can call it r, dr, and I take the derivative of that with respect to x, my answer is equal to f of x. That's what you have to remember.
Okay.
Doesn't matter if this is f of t, dt. As long as we're going from a constant number to x, and we're taking the derivative of the integral, the fundamental theorem of calculus tells us that that's f of x. We choose what we know about logs. Hold on, I'm thinking about this for a moment. The natural log of 4 plus h minus the natural log of 4. How can I rewrite that?
Um, I don't know.
Well, if I have the natural log of a minus the natural log of b, that's equal to the natural log of a divided by b.
Oh, right.
Okay? So the natural log of 4 plus h minus the natural log of 4, I can write as the natural log of 4 plus h divided by 4. And this whole thing needs to be divided by h. Okay? Let's make this look like natural log of 1 plus h over 4 all over h. And the natural log of 1 plus h over 4 must be the natural log of 1 times hold on. How do we get that h to factor out of there? The h is always factor out. It's not non-existent, and I'll tell you why. Because this is the definition of derivative. So they're really saying, what is the derivative of the natural log of 4? which is 0. All right? The derivative of a constant is 0. If I wanted to find the derivative of the natural log of x, we know that's 1 over x, right?
Yeah.
But if I want to use the limit quotient to solve for that, that's equal to the limit of the natural log of x plus h minus the natural log of x all over h. And that's how I solve that problem. And I end up with natural log of x plus h divided by x but if I know the derivative of natural log of x is 1 over x, then this is what this answer has to be. But in this case, we're taking the natural log of 4 plus h minus natural log of 4. Well, that equates to 4 being in place of x. So we're really taking the derivative of the natural log of 4. Well, the natural log of 4 is a number. It's not a variable anymore. The derivative of a number is 0. So A has to be the answer. Even though we didn't do it the way we're supposed to, we can still figure out that the derivative of the natural log, in other words, it's important to notice that since that's the definition of the derivative of the natural log of whatever that is, if it's an x, it's an x. If it's a 4, it's a 4. So taking the derivative of natural log of 4 is 0. This could be 400 and it would still be 0.
Okay.
Okay? There's a different way to do that. And the book actually shows you how to go through and figure what this is. Because in the section in the book where it talks about finding the derivatives of natural logs, it goes through the algebra of finding the derivative of, or finding the limit of natural log of x plus h minus natural log of x. I just don't remember how that algebra proceeds from this point forward. But you can look that up in the book. If you go to the section on finding derivatives of natural logs, it works through the algebra of finding this.
Okay.
All right. It's 9 o'clock. We only got through about a third of these problems. But I guess that we'll have to do with that, huh?
Yeah, I think that was some good review.
Okay. I'm only sorry we weren't able to review the whole thing.
Oh, no problem.
Certainly good luck on your AP test. What do you have to get on that thing in order to get college credit? What do you have to score on the exam?
A 3 is passing, but I don't know exactly which college I'm going to go to yet. But I'm hoping to get
What is passing?
a 3 is passing.
A 3?
Yeah, out of 5.
Oh, okay.
And then, but I'm hoping I can squeeze up to a 4.
And the higher you get, obviously, the more impressed a college is. Are you a junior or a senior?
I'm a junior.
You're a junior. Okay, so you got lots of time yet.
Yeah.
What are you going to take next year?
I'm going to take statistics.
You're not going to take Calc BC?
No.
Okay.
I thought it would probably be a good idea not to.
Well, I don't know. At least I could help you with Calc BC. I don't tutor statistics and probability, so because I've never had anybody ask for it, so I've never bothered to refresh my skills on that.
Oh, really?
Maybe I'll figure out what book you have next year and get a copy of it, and because I am starting to see a lot more students they're starting to teach statistics now much earlier. My Algebra 2 students are getting a little bit of statistics now.
Oh, really?
Uh-huh. So I probably do need to be able to tutor probability and statistics. So don't forget about me totally next year. If you still
Okay.
are in need of a tutor, let me know.
Okay.
Although, if I were you, I would consider taking Calc BC. I really would. For one
Really?
thing, the B part of Calc BC you've already had, so the whole first half of the semester is going to be review. It's only the second half of the semester that's going to be really tough. And how it's going to be tough compared to probability and statistics, I really don't know, since I don't really know the probability and statistics. But the only thing I know is that I could definitely help you on Calc BC. I might not be able to on probability and statistics.
Right. And
Okay?
I'm taking AP statistics, if that makes a difference or anything.
Take an AP statistics.
Yeah.
It's not called probability and statistics, just statistics?
It might be. I'm not sure the official
Okay.
title.
Okay. In order for me to help you, I'd probably have to get a copy of your book. And I don't really
Okay.
mind doing that since I don't have a good probability and statistics textbook. So I would consider trying to help you if you need help next year. But
Okay.
it kind of depends on how many people. If you're the only person I would have, then it's probably not worth it for me to spend 20 hours refreshing my knowledge on statistics.
Right. Yeah, that makes sense.
So that's why I've never really tutored it, is because I've never really had anybody ask. So, all right. Well, listen, good luck on your test tomorrow.
Oh, thank you. Thanks for all
And
your help.
sure. And I'll talk to you next time.
All right. Sounds good.
All
Thanks.
right. Bye-bye.